I'm Adam. I'm DevOps engineer at acaisoft, and I would like to talk a little bit more about infrastructure and from code narrator standpoint of view. As you see in our topic, we run this in Code Llama and with Runpod Cloud. But why we do this? Let me tell you, how we achieve that. So, first of all, if we talk about LLMs, about AI, the first question is why not use GPT for this case? And this is a good question, because we actually run our code narrator with this GPT. So we checked that. And these are some additional info about ChatGPT. For example, GPT-4 has 1.7 trillion parameters. And this is very huge amount of parameters. For example, other open LLMs have up to 180 billion parameters, so this is a whole tier up. And this is not that pricey solution, because if we look into the costs, this is like 6 cents for 1,000 tokens. And 1,000 tokens, Jerry already told about that. This is like 750 words. And we have huge context, because we have now 32,000 tokens. So this 32,000 tokens, this is like 24,000 words, and this is like, let me see, check in my notes, this is like 3,000 sentences. So this is a lot, but if it's not enough, let's check it. Okay, so, but what are the main concerns with ChatGPT? The first one, we already talked about that in Q&A. This is data security. Many corporations don't want to use ChatGPT because they don't want give data for this LLM, only for that they train their model on their data, and this data will leak somewhere. Of course, this is not an issue if we can trust for OpenAI, but still this is a concern for enterprise. Secondly, reliability. So if we go to ChatGPT and prompt something like question about some topic what GPT doesn't know, then ChatGPT hallucinate. Of course, OpenAI fixes that, and it's really better than before, but still we can find something. For example, I asked ChatGPT about references for the statement that drinking alcohol is bad for me. And okay, I have a lot of references about that, but some of them, for some of them I had page not found. And this might be the two reasons here. One, hallucinations, and the second, that data is outdated. As Jerry mentioned before, these data are from 2021. So this is not the latest data. So we cannot use it for our purposes. Okay, and third, legality. Because sometimes we have legal agreements with our clients that our data should be stored in restricted area. For example, one country. That might be for some bankings. Yeah. Next, fine-tuning. Fine-tuning is very pricey in GPT, so yeah, pricey. Okay, and the last of this, context limit. We have only 32,000 tokens. So for our edge cases, that might be not enough. So we need to check something more. If there is maybe LLM, which provides for us more tokens in our context limit. Okay, so if not GPT, then what? Maybe we can check some LLMs. There is some web page, Hugging Face, where we can check many different LLMs. They have like 120,000 models. So how we can find something in this? There are some leaderboards. For example, this one. This is leaderboards with high scores in some tests for these LLMs. And we have in the first position Marcoroni LLM. This is interesting case because this Marcoroni doesn't exist 2 weeks ago. So this means that this leaderboard is very dynamically changed. But there is another leaderboard, and we use that to pick our LLM. And this is Big Code Models leaderboard. This leaderboard focus on LLMs with code analysis. So as you see here, most of them are based on Code Llama. And when we check that, this leaderboard, actually Code Llama was on the first place. Now some fine-tuning was happened here, and we have some other models here. Okay, but if we have this Code Llama, and this Code Llama, it's really good when we compare it with this leaderboard from other cases. But what else? Because if we have LLM, we need to put somewhere this. Yeah, so we need to have some infrastructure. For GPT, we had this out of the box, but here we doesn't have. So maybe let's create data center. Yeah, we can rent some house, buy some hardware, and create data center. But there is one issue. Yeah, only one NVIDIA Tesla A100 GPU card costs $18,000. So this option is out of the question. But why we even need this GPU? Yeah, because if we say LLMs, we say we need a GPU. And why? Because its structure for GPU, for graphic card, we have in CPU we have a smaller amount of cores than in GPU. This is because design is for CPU, it's designed for serial processing, and for GPU, it's designed for parallel processing. The best way to explain that, I think, it's by example. When we have a restaurant and we have head chef, this head chef is our CPU, and we have some clients, and a lot of the clients, like 100, and these clients needs, they want steaks. And this head chef can do that, can cook 100 steaks, but it will take time. But he can hire junior assistant. And this junior assistant with 100 hands can cook these steaks. Yeah, this junior assistant is our GPU, of course, with 100 cores. Of course, this GPU for AI is a lot more complicated, yeah, because, for example, a GPU A100 has up to 7,000 cores. So this is a lot more. Yeah, so why we need this GPU? For example, Code Llama has 34 billion parameters, and it's compared to 70 gigabytes space. And we need to take this 70 gigabytes data to data model to our graphical card and try to run parallel. Yeah. Okay.
Your multiple GPUs. Those 70 gigabytes of data, can you load on the multiple GPUs, or do you have to
you can load this on one GPU, of course, but this must be 800 with 80 gigabytes memory. Yeah. Then we can.
GPUs, but multiple of them.
Yes, you can do that, and we run this, of course, but we faced some issues here. For example, when we had two GPUs with 38 gigabytes, sometimes it break. So I'm not sure why. It's still to investigate. Yeah. Okay, but if we doesn't create data center, then we need something more. Yeah?
So you are using some local LLMs, which probably you are fine-tuning from time to time, or maybe regularly. Yes?
Yeah. Yeah.
Okay. So you showed us the leaderboard, and you showed us the dynamic of changes of these LLMs. So in fact, you are investing in the fine-tuning of some LLM that may be obsolete next week.
Hence, we picked Code Llama because it won't be changing that dramatically. And the other LLMs that were shown there, they're actually fine-tuned Llama code, right?
Yeah, okay.
So that's something what we do, but we fine-tune them for our use cases. So they are like localized to us. And they do not need to be the best LLMs coding in every language. We just want them to do what we want them to do all the time. But yes, you're right. At some point, probably we'll need to do the fine-tuning on the scratch, maybe on another model.
Yeah, this is speed racing. Yeah.
Yeah.
Okay, but back to presentation. Okay, if we cannot create our data center, maybe we can use some public clouds. For example, GCP, Azure, AWS, and they all have option with instances with GPU. So when we use GPU 800, because this is the most common GPU for LLMs. As you see, GCP cost on GCP that instance cost more than $6 per hour, and for Azure and AWS we have more than $27. Of course, for Azure and AWS we have instance with 8 GPUs, but we cannot scale this down to 1 GPU. That's why I presented that price here. And the last one, Runpod Cloud, on demand is only $1.69. But there is one issue from my standpoint of view, that Terraform provider is not available here, and it hurts for DevOps like me. Yeah, but of course there is API, so we can create our custom pipelines and keep this infrastructure as a code still. Okay, so maybe I would like to show some solution based on GCP, because we tried that for AI projects, and we checked that and it works, but there are some issues. Maybe I will explain you later. We had Git repository for everything, for Terraform code to deploy infrastructure, for Helm charts, so we could run resources inside Kubernetes, because we want Kubernetes, because Kubernetes has autoscaler, and we have code with to create build image. We have artifact repository inside GCP to store these images. We have GCP bucket to upload our LLM model, and we have CSI provisioner to connect our GCP bucket to our pods. We have Argo CD to maintain our changes inside Kubernetes, and we have to monitoring cost-free Prometheus, Grafana, and alerting. Of course, and it looks really good from my standpoint of view, but there are two issues, connected issues. One is availability, because when we created that with Node autoscaler, then we had this issue when we tried to scale up our Kubernetes cluster. Then it said that there is no GPU instance available, and we faced that many times. So that wasn't the best solution, and the other solution is to keep one instance with this GPU all the time, and this is very costly, because if you calculate that, this is like $6 per hour, so this is like $4,000 a month. So what are our alternatives still? So maybe Runpod. Runpod without Terraform, it hurts for me, but still, it's
What Terraform is doing?
Terraform provides easy access to keep your infrastructure as a code. Yeah, you can keep everything in Git repository then, and yeah, that's it. Yeah, you don't need to click this in UI GCP or create it manually, because this creates some problems later, because you created something and you don't remember how it works and how you can recreate this on other environments. That's why I prefer use Terraform for this. Of course, so we have other solutions, but this is, I think, the most popular one. Yeah. Okay. Back to Runpod. So we have this Runpod Cloud, and this Runpod Cloud is AI focused, so designed to support AI solutions. The second one, price. This is 3 times cheaper than GCP instances. Third one is serverless. We can pay only for this time when we run it. So and this serverless feature is only in this Runpod for now. We don't have it in GCP, AWS, or Azure. Of course, AWS has Lambda, for example, yeah, but this is not with GPU. And in Runpod we have it. And the fourth one, availability. We faced less issues with availability than with GCP. Okay, so let's check how it could work. So diagram is much more simpler than for GCP. We have Git repository to create some images from that, and in Runpod we can create only template with this image, and we need to run pod. This is query for Runpod, because we need to create pod inside Runpod to upload data to our storage, and then we can terminate this pod and forget about it, and then we can create serverless endpoint from template and storage. And this is Runpod. This is Runpod UI. It's very simple because it doesn't have any more than we need to create our AI solutions. For example, in GCP you have networking, you have DNS clouds, and etc. Here you doesn't have it. You have only this custom templates, endpoints, and when you create that, you have only this form to fill that. So you need to add some name, container image, maybe some comment, and then some environment variables. And we have, of course, logs, yeah?
What about spool up time? So you pay only for running time. So when you stop, spool it up.
Yeah, you mean cold start, yeah? Okay, so actually this is a very good question, because I will talk about that in a minute, okay? Okay, so we have logs, we have metrics with cold start time, as you mentioned before. And what are challenges? Because this is not the ideal solution, of course, because this is, I see for Runpod Cloud that they have a large community inside Discord that they talk about how to approach to AI solutions, and they creating this in our even now, yeah. So what are challenges? So first of all, cold start, and we have cold start. This is the time which is required from from first request to our instance to the time when that instance will be in running state. So, and this is right now in 38 to 132 seconds right now. By the way, this is a lot less than before, because when we tried this the first time, we had 4 minutes, but Runpod actually released like, I don't know when, but in the couple of weeks ago, yeah, this feature, Flash Boot, and it works, because we could change that time from 4 minutes to 2 minutes. Yeah. The second challenge is response time. We have 100. Actually, for now, for 2000 prompt token, we have response time for 144 seconds. It's not that good as we can create, because GPT has response time like 20 couple seconds. So we have a lot room to improve here, of course, but still we have a couple thoughts about that. We have some ideas how to improve that. For example, we want to use some other our code with other languages and check if this time will be much faster. Okay, and next, for now, our solution can only take one request per instance in the same time. We are working on parallel answers, but for now we don't have it. Next, this is my Terraform provider, but we can create by ourselves, so this is not the issue. We can create custom pipelines, so this is not that huge issue here. And finally, cost. For now, for 2000 prompt token, this is like input tokens, and when we have 4000 output tokens with our Code Llama, we need to pay like 19 cents for that. But this is a lot of better than for GPT-4, when we should pay for that 60 cents. So, of course, if we run our code with response time, with smaller response time, then our cost will be much smaller, because we pay only for this response time in Runpod. And thank you.
This is for a single request, right?
For a single, yeah.
So you have to like make a request, wait over 2 minutes, and then you can make another request later.
That's right. This is of course for code narrator. Sorry, it's not that important as for other applications, because code narrator, you need to. If you run code narrator, you have this answer after 2 minutes. And if a developer would look on this code, it took a lot of more time than 2 minutes. So I think this is not relevant as the cost for that response.
Yeah, and we can always spawn more workers, right? Because the workers are kind of cheap, they're serverless, and that's the limitation of one worker, but we can have a lot of that.
Okay.
So like the what Adam showed, there was like 5 workers or 6, so they actually give you that and we can work in parallel. Yes, request.
Also did.
Yeah.
So I don't really get it because you have here these requests. Is it when I'm making a call, is it this when this request is being made, or it is just for batch processing? Let's say I wrote like 5 megabytes of code. I put this in, and it's working half of a day, and I have a cleaner code to track. What is your service?
Now we have embeddings for that. I believe, yeah.
Let's go with that question once again. So
Yeah. Okay. So I don't know what is your how your service is being served. So let's say I am writing the code and it is assisting me during making the code, or it is, let's say I have already a finished repository, but I think it could be better, yeah, and then I just put it in and it's in batch processing, yeah.
So we are working on your commits. So first time you connect your repository to our solution, we are going to crawl the full repository and factorize all the subdomains. So like get the documentation, prepare the initial prompts what can be done, and then each time, then you can review it and work with that. And then each time we do a commit to your repository, the new code will be analyzed as well in the same manner, but there will be less code to analyze. And the prompt that I mentioned, like those 2,000 tokens, it's like the average we notice when you work on a one file, that is most of the time is average 2,000 tokens in the one code file, and start with the estimation based in this.
So it's not when I write the code; it's when I make the submission to the repository. Okay.
Yeah.
Main question: have you considered running gaming GPUs? Because I find like 3.0, the latest generation of used GPU cards is actually the least expensive, because I did the calculations. Okay, I need to calculate this much of like compute, this much of LLM processing, and those enterprise GPUs are like 5 times or like 10 times more expensive than those.
Okay.
You can have cars that can run this one model. I think it can fit on like 3-4 GPUs, and it's quite reasonable. So like to 20,000 zlotys or something like for the setup.
Yeah, but as I mentioned before, when we run our code with 2 GPU with as half memory than our this 800 with 80 gigabytes memory, then we faced some issue and performance issue too. Yeah, when we run this, that was like 2 times longer than with 800. So yeah.
Yeah, there's one thing I think that me. Hello. I just want to get additional context why we're doing this compared to other options, because we're not going to buy hardware. That's why we're using cloud, because it's not scalable to buy hardware for us. So we're trying to find something that we can scale up, and this is still initial testing. The thing is, as Adam mentioned before, because we are not like Copilot or any other assistants, we run this work in the background, so it doesn't matter as much how quick and efficient it is. It can go for 2 minutes because we're solving a problem that engineers will have to take 1 day or 2 days to solve. And because this is happening in the background, this is secondary. The other thing is we're constantly improving on how quickly this model will run. And the benefit of this is we're not running constantly. So the serverless approach allows us to trigger the job and just wait till it's done, and just pay for that amount of work that was happening. So just to answer the question, we're not really considering creating our own hardware or getting the hardware. It's not our space. We focus purely on cloud-native approach and to use what there is already hosted. So we're trying to find out of these options the best solution that we can have for the solution that we're building. And we're, of course, constantly checking other options. But this is, and basically these times look strange, but the thing is that this is not ChatGPT-like experience. If you go through OpenAI API and want to achieve similar stuff, it still takes time. As Adam mentioned, for these questions, it was 20, 30 seconds, which as a users of ChatGPT, we're not really used to. But these models take time, and probably a lot of things that are related to this time that's running here is really how we are running this in development environment. We are now working on using, because a lot of this is still running with Python, we'll be looking into direct C++ or some other more performant solutions to speed up the development, to speed up the inference of the model. So just wanted to give the context why we're at all using Runpod. But we think it is really interesting, it's easy to set, and from cost perspective, you can just run the question, get it done, and forget about it, and not pay for infrastructure that you forget to turn off. So that's the main reason.
Yeah. You mentioned using public models. Do you take them as they are, or do you later fine-tune them yourself?
Public models, LLMs, yeah?
The answer will be both. Like, we start with the birth model, and then we try to fine-tune it for our use cases.
Yeah, basically, this is one of the main reasons why we want to have self-hosted models, is to be able to fine-tune them. And this is what we're doing. But there's still a lot ahead of us in fine-tuning space, because the key challenge is to create the right data sets, and it takes time to prepare them. So, but generally, one thing that happened in the meantime is that OpenAI released an option to fine-tune GPT 3.5 model. But this is not something that we've been looking into yet, especially because one of the things that I've noticed at that AI conference is that people are really asking for self-hosted models. So as well as part of our R&D at acaisoft, this is super interesting for us to verify what is really required and how far we can get with self-hosted models. So that's why we're investing more time into fine-tuning self-hosted models. Yep.
When it comes to the fine-tuning, do you have success with implementing like knowledge from a project using fine-tuning? Because normally I think, and with my experiments, fine-tuning is for customizing the way the model responds. So response format, the style of response, it is very, very weak, at least from my experiments, to implement some knowledge. So
we are purely approaching this to get the expected outcome of the model. We're not fine-tuning it for knowledge at the moment. Because that's why we're using, and the other reason is that fine-tuning for knowledge is way more expensive. So we're relying on others' expenses to be basically able, that's why we're using this Code Llama. And as somebody asked before, yes, these models are changing, but the amount of fine-tuning that we do is not crazy. I mean, these are not, I don't know, tens of thousands of dollars of fine-tuning cost. Basically, the overall cost of fine-tuning so far is a couple $100. So this is a reasonably repeatable process that we can achieve. And the main thing is that a lot of our work, as in the first presentation, is around prompt engineering in some way. And once we establish some solution that works, then we focus on fine-tuning it so we can free up some of that context window space. And what we are exploring now is, and we're still not sure, but it may not end up with multiple models that are fine-tuned for different cases of fixes that we need. And this is still, that's why solutions like Runpod that will allow us to run multiple models in this serverless fashion might be a solution. But this is still part of a quite heavy R&D aspect, so we don't have very detailed answers on that.
Yes, but I think also there is a misconception about fine-tuning, because when you have a data set for fine-tuning, you have this data set, so you can take a new model and apply this new data set. So it's not like you're fine-tuning this model and it's a lot of work, so you need to do the same work on the new model. You just have a data set and you just apply on the new model.
Yes, and there is as well a level of balance, because this is what we're testing as well, how big of the model we really need, because the bigger the model, the bigger the data set needed for fine-tuning. So it's not always the answer is to have the biggest available model, because it has some drawbacks of amount of fine-tuning data that you need. So that's why we tested 7 billion models, but they are not as good right now as you could see through some screenshots. We're on 34 billion models, but there is constant improvement in this space as well, which means that less parameter models are actually behaving quite well. There's like recently, what was this, Mistral AI that recently popped up, 7 billion model that is comparable with 13 billion model of Code Llama. So this is really a really interesting space that changes happen daily. And a lot of this is constantly researching, finding the best solution of how to apply this business-wise as well, so it's even reasonable to use. So, yeah.
What is your potential best client? Like the model client that you are looking for, what would be the best client for you? I mean, who do you really address?
Big budget.
But I mean, is it a single developer or is it a...
We're rather, as I said, generally as a company, we're focused on enterprise customers. And that's why there is this temptation for self-hosted models, because this is what at the moment is convincing these customers. So we're exploring a couple of projects with our existing customers, maybe not as detailed space, but in some similar areas. For example, we have customers that approach with quite typical questions. Let's say we have our HR and inventory data, and we would like to have ChatGPT-like experience to query them. So for that, for example, we're testing an option to fine-tuned model that is capable of converting human language into SQL queries. And that works pretty nicely. So, and that customer is approaching and saying, well, I basically, through our current legal policy, we cannot use OpenAI. So basically, that's why having this option at the moment to give to the customers, hey, we can host it for you. This is what we tested. These are the limitations. This opens some possibilities as acaisoft to work with customers. But things might change. Recently, Amazon Bedrock happened, which allows to run models in Amazon. There is Azure services that allow to run hosted models. Google has Vertex AI, but they are still limited to their models. So things might happen in a month or two. All our work can just be thrown away. But that's why I mentioned, like, we're really engineering driven and strong focus on R&D. If it happens, it happens. But so far we're exploring this, we're learning a lot. And we think that independently what happened, it will benefit on the product development. But that's the risk we're taking, basically.
So we are talking about self-hosted, but actually all this is done in the cloud. So many of the concerns with ChatGPT still apply. Like there's data set open network to somebody else, and I feel like many enterprises will not like that as well. So are you exploring maybe hosting this on the hardware of somebody else when you don't want it to do it yourselves, like the actual local solution, maybe a weaker, smaller model size?
Yeah, good question. And the thing is that self-hosted is sometimes maybe misunderstood or misused, because really what enterprise thinks by saying self-hosted, is it gonna run in my subscription? So it's not, oh, I need to run it on-prem, but basically nowadays, at least in the space that we work with, all the enterprises have their cloud subscriptions, and all they ask is, can I run it in my cloud subscription? So yeah, from that perspective, there might not be okay with Runpod. That's why we're exploring what Adam described before. We are able to run these on GCP and other clouds because we have quite a lot of experience with Kubernetes. So running these models is still viable there. So this is an option that we do for customers. But this is not an option that is financially viable for us as acaisoft. That's why for a code narrator, we're running Runpod, which we thought will be interesting because it's just a cheaper solution. So for testing and playing, this is really a great starting point to run your own models. Of course, there's still some other options, like you can just go directly to Hugging Face or some other hosted options and run these models there. But for us, this serverless approach is really interesting and tempting. That's why we're exploring it. But yes, exactly, the question is correct that enterprise customers really by self-hosted mean running in their own subscription. Yes?
So when you're talking to enterprise customers, are they, 20 years of enterprise software experience for myself, are they looking to purchase this inside their corporate infrastructure for their team, or are they looking for folks like you to come in and teach their team how to do this? Well, what's that market looking like now?
From our perspective, this is really because we focus on custom software development. They approach us to implement it for them. But this is what we've been working on from the very beginning. We always work in customers' environments. So far, these were CPU-based environments. Now that GPU becomes a thing, and as Adam mentioned, availability of these GPUs is limited. So far, there are required clever ways to solve that problem. And if you will look through the AI space and the investments, majority of the investment goes to NVIDIA to purchase the GPUs. So that's kind of funny now.
Did you try the Cloud 2, 100K or not? Cloud 2.
Oh, Cloud 2, the Cloud from Anthropic. We haven't used it. We played with it because it is interesting because it has 100,000 tokens context window. But that model is not really, per my knowledge, fine-tuned for coding. And there's as much as, we cannot test them all. But definitely it's now getting more interesting with AWS investment of 4 billion in Anthropic. There might be, and that these models are great, but we haven't tested that really in detail. So, yeah.
Do you have an API access to Code 2?
No, not yet, I think. But I don't think we got that. We were just testing, just some stuff online. But
well, I'm more from business background, so I studied at Warsaw School of Economics. I'm just trying to pretend an IT guy from Pelham. But I look at this, and even when I plan my career, I feel this risk that from one day to another, a lot can change. And as you mentioned, it may be that in 2 months from now, most of what you did will just go to trash, yeah? How do you see this? And I don't know how long your co-founder already exists, and probably you already went through some bumps, yes? And how do you see this in the future? Where are the niches? Because I was recently thinking, what is the most probably the safest niche that corporations will not take for quite a long time, like at least 2-3 years? Is there anything like this that you...
But you mean from perspective of using AI or these models? In which space?
I mean developing any product in AI that it will almost not for sure be like offered by OpenAI or Microsoft or I don't know someone
answer
tomorrow. Yeah.
like there is easy answer like things that are pornographic, like illegal, and like corporations won't touch it. So if you want,
Okay. Very good. So now I know.
Yeah, this is really open-ended question that probably we can take offline discuss. Just high-level answer is on our experience. So, as I mentioned before, acaisoft has been around for more than 8 years now, working from the very beginning with US customers. So we were lucky enough to be really exposed to the latest changes of the IT. For us, there was a big shift early on to containers, and we jumped on Kubernetes very early. That helped us a lot. We grew, so basically, it may be not visible here, but we are almost 200 people now. And yes, we went through different bumps, and we still don't have answers to this as well. I mean, I was right now 2 weeks in Silicon Valley meeting with customers, and basically everybody is asking the same question: is what will happen with this, right? Even at the conference itself, the other companies that had their booths, so it was either some infrastructure providers that just selling shovels, and any product-based company. Basically, from my perspective, none of them were really as advanced to just state, oh, there's fully functional end-to-end product. Everybody is really in that R&D space. And we're trying to follow what's happening in this market. It is hyped market. It's hard to say. There's a lot promised that it can do, and then people test, and it's not as much as it can do. So this is still a huge unknown, but definitely there's a huge value in these models. They solve a lot of interesting problems that we couldn't solve before. So I strongly personally believe there is something that will happen in the market through these models, but it's really hard to predict where it will hit. I think what is the most surprising is that for years we thought that simple jobs will be the ones to be basically substituted by AI, but what's happening is really these advanced jobs are being substituted. So I think this is one of the most interesting, but as well, like with Code Narrator, I don't think it will make engineers irrelevant. Like with all the other progress, it will just make us engineers able to focus on the interesting stuff and have these models solve some of the stuff that we just don't want to do. So this is basically the hope that I have. But I'll be happy to discuss this further over there.
There's a big question in this area. I noticed that most of the time AI can deliver like maybe 70–80% of accuracy. Like it usually works okay, but you still don't have 100%. And for many products, client will just say, "Well, sorry, it's not working always. We do it the old way, yeah."
It depends what you put inside of this data, yes. Because right now, as I understand it, works like that a big amount of data just put to this ChatGPT, and they give just statistically right questions. So they are just choose statistically. And for example, when you put to this database, I don't know, that's for example, Earth is not circle, but they are stay in I don't know in what. Yes, they are not circle, they are cubical, and if you have a lot of this kind of information there, this chat gives you this information. So it depends, I think, what you will have there. That's why, and this is not 70% correct.
Yes, and the thing is, in some way, like with humans, right? We base on the knowledge that we have. So trash in, trash out, and actually this is quite important area of research now, is to have as great data sets as possible. But we shouldn't look at these large language models as, you know, pieces of code that just always answer the same way. This is, in a way, that's why great utilization is in this creative work, right? Image generation, audio generation, because we haven't really touched this. We're just discussing code. But in the areas where this kind of hallucinating aspect of the model might be really advantage, right? So I met, for example, an interesting guy over there that is working on a startup to help people write books and use these models to create that content based on the notes that people create. I think it can open a lot of new opportunities that were not possible. And actually, it will be a feature, not a bug, that they can hallucinate a little bit. And some of this is controllable. But I don't think we should look at these models as a precise solution. For that, we already have better AI systems that give better performance, they give better classification options and all the other stuff. I think as a general outcome of, let's say, today's discussion is let them be creative, because that's why they were built. And I think this is the biggest asset of these models, that they can be creative. So, yeah. But I think let's move the conversation. It will be better with a beer and some snacks, I think. So thanks everybody. Thanks, Adam.
Thank you.